Hello, everyone. Thank you for having me. My name is Flor REGUS, and I am a third-year student at the IMBE and the LPED. So today I will present some of the results that I have from one of my experiments called Effects of Massive Organic Amendment, Irrigation, and Grass Cover on the plant-soil continuum in viticulture. I just want to also say that my PhD is financed by the ITEM Institute under the ALCOP project. So just a little bit really quick about what the ALCOP project is. It stands for Agriculture, Biocontrol, Bioamendment, and Viticulture, and it is a multidisciplinary project that one of the goals is to find alternative solutions for the use of agrochemicals, more importantly, the use of pesticides. So going back to the study that I am going to present, a little bit of the context as to why this is important. So we all know that the imminent changes of climate change are here. That means for viticulture in the Southeast France, that we're going to have more frequent and more intense heat waves. On top of that, in viticulture, you have a lot of intensive practices, just such as the use of tillage to prepare the soil and the use of agrochemicals. The thing is, over time, the use of these intensive practices deteriorate your soil and the biodiversity on the soil. So because of that, there is an urgent need to change agricultural practices, and there is a need to also evaluate these new sustainable alternatives. So for this part of the study, what we wanted to know was if massive organic matter amendment and the use of grass cover are beneficial practices for soil quality in the Mediterranean context, especially in vineyards. So our hypothesis was that massive organic amendments and grass cover favor the living part of the soil. We know from the literature that the use of massive organic amendment increases soil nutrient availability, benefits soil microbial biomass and mineralization of nutrients. And on the other hand, we know that the use of grass cover benefits nutrition cycling, microbial activities, increases soil microbiomass, and it also acts as a physical barrier against erosion of the soil. So moving further, for this particular study, we partnered up with the Association des Vignerons de la Sainte-Victoire. And for this part of the study, we did 4 field campaigns, one in early June, end of August, December, and March. And for this study, what we had were 4 modalities. We had a control where there was no organic amendment or grass cover. We also had, one with massive organic amendment, one with grass cover, and one with both modalities. And we had a total of 32 soil samples. So what we wanted to do in the overall study was to, like I said, study the effects in the soil and plant continuum. So for that, we looked at the soil biomarkers. We looked at the physical chemical parameters such as granulometry, conductivity, copper content, pH water, pH KCl, nutrient content, water holding capacity, or total organic carbon. And for the biological, we looked at the microbial activity, such as respiration and biomass, and also catabolic diversity using biolog plates. And we looked at the macrofauna in terms of the abundance of earthworms. For the sake of this presentation, I will only focus on the microbial results. On the other hand, we also looked at some plant markers. We mostly looked at the phytometabolites using spectrophotometry, and also at the organic matter quality of the leaves. So a little bit of my results. So as I said, for the soil microbial respiration, we looked at, we are looking at the results from June and August for this presentation because those were, to me, what had the most striking, interesting results. So in the month of June, we have that both there was a significant effect from the addition of organic matter and basal respiration. They both resulted in higher respiration rates. However, if we move to the month of August, there was only a significant effect from grass cover, which, as you can see here, it was higher. The respiration where there was grass cover than without it. To sustain also these results, we did the soil catabolic structure for both bacteria and fungi. And here is just the results of a PCA for the soil catabolic structure of bacteria. As you can see in the month of June, there is a difference between my control treatments and all other treatment modalities. And then moving forward in the month of August, there is a difference between both modalities, meaning the organic matter and grass cover, versus all my other treatments. So the similar results are for the catabolic structure for fungi, where in the month of June, the control is different than all of my other treatment modalities. And however, here in August, we have that the main driver in the differences is the grass cover. So to conclude, in the month of June, we see an effect of organic matter. We see a positive effect in microbial respiration. This is sustained by change in microbial catabolic structure. And we also saw an increase in total nitrogen content in soil. There was also a significant effect of grass cover, where we saw positive effects on microbial respiration. Now, when it comes to our results in June, I didn't put the graph here, but there was a significant increase when using grass cover in terms of water holding capacity. We saw as a positive effects on microbial respiration, and this is sustained by change in microbial catabolic structure. This could be due to the aerial part of the plants being, dead and decomposed. So overall, we saw in this study that the application of organic amendment and grass cover have a positive influence in soil microbial activities. We see that grass cover and organic amendment help the soil maintain its functionality during drought season, meaning June and August, versus those in December and March. Also, an interesting result is that the effect of organic matter is still observable more than 6 months after the application. So overall, in this case study, the use of sustainable practices was overall beneficial for soil microbial communities. Thank you.